Hi everyone, it's Scott Castrol again, and this is going to be the last in my series of CAST practice questions. This is actually going to be the CAST training test we're looking at right now, and we're going to show you some of the questions from that. There are a grand total of 11. Before we do so, I do want to remind you, please, I want you to vote for me. And let me see if I can flip this. Yeah. And it is americasfavoriteteacher.org, 2025/Scott Castrol. This is the last week until the quarterfinals. I'm in 5th place. I need to be in 1st if I'm going to move on. So let's start with the test. A student studies how populations in a kelp forest ecosystem off the coast of California are affected by their food sources. The two graphs show a change in population of perch, a type of fish. Actually, one thing I want to do, presenter view, that way I can use the tools, turn on the pen. All right. A type of fish also affects the population of sea otters. So what you can see is the more perch you have, the less sea otters you have. More gives you less, which is important because that brings us to the actual question. Here's the diagram shows a partial food web. So what you should see is the producer here is the kelp. Perch eat the kelp, and so do sea urchin. Otters eat sea urchins, orcas eat both sea otters and perch. That's basically the way you should see that. And that's going to help us in understanding why it happens. So here's our food web again, but also remember our graphs. So remember, more perch gave us less sea urchins. So the answer for the first one is obviously going to be decrease. You can see that from the graphs. And if you forget, there's the graphs, right? But what about kelp? Well, if we have more perch, they're going to eat more kelp, right? That's what this arrow means. So again, that's going to cause a decrease. So the answer for that question is that they're both a case of decrease, okay? All right, on to the next question. 2 students investigate the effects of lung disease called emphysema that also affects the alveoli air sacs. Alveoli are found in the lungs. The disease interferes with the oxygen and carbon dioxide exchange between the lungs and the blood. This may result in shortness of breath for the person that has the disease. Persons with emphysema often have heart problems. The first person thinks that having emphysema and heart disease are related, but the second student thinks the diseases are unrelated. Which statement best describes whether or not emphysema and heart disease are related? So let's first add our 4 answers. Emphysema and heart disease are not related because the lungs are part of the respiratory system and the heart is part of the circulatory system. We can eliminate this. If your body systems didn't work together, you die, right? Your brain needs to tell your heart what to do. Your heart needs to pump so that air can get to their cells, the lungs get the air, which is why you have pulmonary arteries and pulmonary veins going between basically the heart and the lungs, so you can get that, you can oxygenate the blood. How about the second one? Emphysema and heart disease are related because poor gas exchange in the lungs means the heart works harder to make blood bypass the lungs. Here's the big word here. Bypass means the blood doesn't go to the lungs. If the blood doesn't go to the lungs, you die. Your cells get no oxygen. Can't be that one. Emphysema and heart disease are related because if there is not enough oxygen in the blood, the heart works harder to get enough oxygen to the organs of the body. Okay, that might be it, so we will mark that and go to the last one. Emphysema and heart disease are not related because people who develop emphysema are not healthy to begin with and are more likely to have other health problems. Well, that's true, but the reason you have other health problems is because your other organs aren't working right. So again, we can eliminate this. The correct answer is indeed C. The heart has to work harder, and that means that it basically wears itself out more quickly. Okay, students are investigating the weather around their school. They collect data from a weather station regularly for 1 week. During the investigation, a cold, dry air mass replaces a warm, humid air mass in the area. Complete the sentence to describe the observation students could make to indicate a cold front passed. Okay, so first of all, did the temperature increase or decrease? Well, it's a cold front. So we can basically say probably cold front means it's colder. Now, what happens because of the cold front? Well, actually, this is something you have to know. The cold air, because it is more dense than the warm air goes above the cold air, and because of that, the warm air goes up. It as it gets colder, it can't hold as much precipitation, water, and you get precipitation. So the answers are decreased and more precipitation. Notice this is actually kind of training you to use the drop-down box. Just click it and it shows you the options. Okay, question 4. Students are studying a compound with white crystalline powder at room temperature. The students build a ball and stick model of this powder, which model demonstrates the structure of this compound. And here are our 4 compounds. And I think you can see the difference. The key word here is crystal. And a crystal means it is a repeating pattern of atoms. I like to say CRPA. CRPA is not crap. Sorry for the language, if you care. But the point is there's only one that's a repeating pattern, and that's A. So that's our correct answer. Next question. Members of a city council form a committee to evaluate how beach erosion affects the coastal ecosystem of Southern California. The committee proposes to replace the sand eroded from the beach with dug-up sand from the ocean. The committee states that this solution will help the beach keep the beach intact and will maintain the health of the coastal ecosystem. For each statement about the consequences of the proposed solution, select whether it is an advantage or a constraint. Focus on these 2 words. Okay, so each is going to be either advantage is basically something good that happens because of it. A constraint is a limitation. You can think of it as something bad that happens. So dug up sand supports the seawalls that are built under homes too close to cliffs. Well, we want seawalls, right? So the homes stay where they are. That's an advantage. Storms cause some of the dug up sand to move and then block a nearby river. Blocking rivers are bad. That's a constraint. Dug up sand that blocks a nearby river then causes harm to fish in an estuary. Fish die. That is bad. Constraint. Dug up sand widens and restores beaches that are used for recreation. Yay, more beaches. Good. Advantage. Sea animals are blocked from laying their eggs on beaches because of dug up sand. Well, that's a bad thing. Animals can't have babies. Constraint. And there's your answer. Once again, the key idea here is advantage is good things that happen. Constraints are bad things that happen. Question 6. This is a performance task, so this will be questions 6, 7, 8, 9, 10, 11. In this performance task, we'll answer 6 questions. Leah is learning to use properties of substances to identify a chemical reaction. She conducts 2 trials. For the first trial, she pours silicon dioxide into water. For the second trial, she pours a silver nitrate solution into a test tube with a solution of potassium chloride. Notice the formulas, because we're going to use the tables in the formulas. The diagram shows the reactants and the products. So when you put the silicon dioxide in the water, basically, and there's the reactants on top around, so the silicon dioxide just kind of settles on the bottom. See, X is the tan powder. The W is the clear liquid. Here, however, we combine 2 clear liquids, and not only do we end up with clear liquid Y, but we also end up with white powder Z. And that is, and if you want to remember the 4 elements of evidence, I like to remember Castrol hates green slime. Castrol stands for color change. Hates stands for heat exchange. It gets hotter or colder. Green stands for gas release. That would be like bubbles or a smell or smoke. S stands for solid release, what we also call a precipitate, gunk at the bottom. So if we look here, what we see is W and X, you don't see a change, but in Y and Z is a change too. 1, you see a color change from colorless to white, and 2, you see that it's a solid at the bottom. And to make our lives easier, we have 2 tables. This is before the trial. So water is a colorless liquid. SiO2 is a tan solid. KCl is a colorless liquid. AgNO3 is a colorless liquid. And we look on this side, here are our tables again. Colorless and tan, let me just color code this. I'm going to color this red. I'm going to color this red. And then here, I'm going to change my color and turn this to green or blue. Oh, black. That's fine. This will be black. So I'll go back here. These are two glasses. Colorless stays colorless, but colorless turns to white here. In the same way, here we have liquid and liquid. Here we have liquid and solid. But here, let's go back to red. Here we have liquid and solid and colorless and tan. And here we have liquid and solid and colorless and tan. These two are the same. These are different. And that's going to tell us what our chemical reaction. So first of all, chemical reaction did occur in W1 or 2, in W and Y and Z, or W and X, because they're different or the same. Well, the answer is number 2, which is actually Y and Z, because they are different. That's the key thing. We had a change in color, and we had a change in, we had a new solid, a precipitate. That brings us to the next question. So once again, let's look at our tables. Identify a property of the substances Leah can use to give evidence that a chemical reaction occurred in one of her trials. Support your answers with examples from the date. So if you can say here, once again, remember it actually turned out to be trial number 2 because specifically a liquid turned into a solid and a colorless substance turned into a white substance. So the answer might be something like this. When the colorless AgNO3 and KCl react with one another in trial 2, the reactants change color, becoming the colorless Y and the white solid Z. And then the white solid Z can also be considered to be a precipitate that comes out of solution. So you might want to add to this, and I won't do that here, but you might want to add as, so the properties that change are color, and we have a new solid or a precipitate. So you might want to add that paragraph there, or you might not. All right, next question. Now Leah conducts another investigation by placing iron filings, Fe, on a solution of copper sulfate, which produces copper and iron 2 sulfate, FeSO4. She notices in the first investigation that the total mass remained the same start to finish. She wonders if this will be true for the reaction. She continues, binds the substance on a beaker on a digital balance. So let me show you what the thing actually looks like. I think I can slip over here. Whoops, wrong one, here. So first of all, notice I have these, so I'm just gonna put these in really quick. Y and Z have properties that are different from the reactants. I already showed you what the answer is, so I'm just gonna write blah here so we can go forward, because what we really wanna look at is 8. So watch the reaction here. There, so she takes her reactants, the iron and the copper, she puts them together, and she gets that. So let's go back to our thing now. So watch the reaction. So here's when we're done. The big thing to notice is 25 plus 71, and you can do this on a calculator. So I do that. If I take 25 plus 71. See, notice I can use a calculator here. 25 plus 71, I get 96. And in the same way, if I go 28 plus 98, see, 28 plus 68, I also get 96. So notice the mass stays the same. By the way, reminder, you also have your periodic table here, which you can look at. You have a button that gives you all the formulas you might need for your test. You have a line reader and zoom in and zoom out. Okay, so let's go back. Okay, so I said, so why is that important? Let's go here. Leah observes that the total mass did not change. She makes a model to help explain why the mass did not change. And here's her model. But you'll notice on her model, the mass doesn't seem the same. So that's the question. While sharing her model, which I put here, with a classmate, Leah realizes it needs improvements. Check the terms that best describe why Leah's model needs improvements. Leah's model needs to improve because the blank, and the first blank is number, mass, or composition of each type of atom for the products is either different from or the same as the reactants. All right, well, you're looking here, what's here? I know you're measuring mass, but look here, we're not showing what the mass is, we're showing what the atoms are. If you look specifically, 1, 2, 3 reds, which are iron, only 1, 2 reds. Likewise, 3 whites, 2 whites. And then 3 of these, 4 times 3 for 12 yellows and 3 blacks. But here again, you only have 8 yellows and 2 blacks. So the correct answer is it's the number of each type of atoms. And of course, it's that they're different. If it worked, the number of atoms, even though the molecules are different, the number of atoms would remain the same. That is the law of conservation of matter. And that's what you need to know in this part of the problem. The atoms and the masses are staying the same because of the law of conservation of matter. So how do we improve it? Once again, let me show you the toy. But before I do, I can show you the toy right here. I keep doing that. Number different. All right, if you look here, right, you see the key. You have iron, copper sulfate, and you want to try and move these around. So for example, I might move this here and move this here, and you will see, ooh, it looks balanced. What if I go here? It's not balanced anymore. What if I go here? It's not balanced. And if you look at the bottom, right, you can see that you want to hit the submit at the thing. So let's just submit like this, and you look, whoops, try it again. Here it's 3 and 3 when it's correct. Let me just try when it's like this, and you'll notice, whoops, wrong number of trials reached, so I guess you can only try it once. So I will, see if I go like this, it's going to once again continue. So it only gives me 1 trial, which is kind of silly. I have to wait till it's balanced. But I did make a copy of what, which is kind of silly. I have to wait till it's balanced. But I did make a copy of what it looks like. This is unbalanced, and this is balanced. So let's take a look here. I want to look quick specifically at the Fe. Now I'm going to take and this. What I'm going to do, I'm going to look at the Fe's, the Cus, and the sulfates. Here I have 3 Fe's, I have 3 sulfates, and on the right I have 2 Cus and 2 sulfates. You see, they don't match. The Cus, right, if you look here, 2 Cus, 1, 2, that's okay. 1, 2, 3 irons, but we only have 2 irons. And we only have 2 sulfates versus 3 sulfates. It's not balanced. Let's look at this one really quick. First of all, how many coppers? 1, 2, 3 coppers. 3 Cu. Here too, 1, 2, 3. So 1, 2, 3. Next, let's count our iron. Let's count our iron. 1, 2, 3. Here too, I have 1, 2, 3 irons. What about our sulfates? Let me change color again. 1, 2, 3, 1, 2, 3. The key idea is that everything is balanced here. While here, let me just try and get the eraser, erase all. If I go do it here, right, 1, 2, actually 1, 2, 3. Oh. This again, 1, 2, 3 versus 1, 2. Not even counting the other stuff, you can see it's not balanced. So that's why we want it so it's +1 and +1. Okay. Next question, Leah repeats the reaction, adds a great number of Fe than before. The total mass of the project, the system, did not change during the reaction. The additional mass of Fe remains unreacted. Let's circle this word. That's very important. The 2 changes, so another important word, they bolded it, so we want to mark 2 of these that will, to the model that will correctly show how the reaction proceeded with a greater number of mass of the Fe. So once again, the big idea here, we want to see 2 of them. So first, unreacted Fe on the product side. Yes, we will have more unreacted iron when we're done. Will we have a different number of copper? The answer is no. we're not changing the copper, we're only changing the iron. An increased amount of iron on the reactants, that's how she started. Increased amount of iron sulfate. Well, you have more iron, but you don't have more sulfate, so this is incorrect. And a decreased amount of copper sulfate, again, not going to be a problem because we're only adding more iron. Now, if there was more copper sulfate to react to, then there would be more. But because, and if you look here, right, all we're asking to do is add more irons into the system. If I add more iron into the system, I'll just do it like that, you'll see they have nowhere to go. So they just stay iron. So that's why that answer is correct. Let's look at the last problem. Leah's model can also be used to show that a chemical reaction occurred because the products, what? Are they the same size as the reactants? Not necessarily. They could be different size. Small molecules can make big molecules. Big molecules can break up into small molecules. Do they have the same composition as the reactants? No. The whole point is you have different molecules. Are different states of matter? Well, possibly, but not necessarily. You could have two liquids become two different liquids, but have differently arranged atoms compared to the reactants. That is what we want. That's the point. The reactants are exchanging electrons, and doing that, they're arranging themselves differently. So that's the last answer. So I hope this helped. Once again, please vote for me at americasfavoriteteacher.org. It's 2025 Scott Castro. If you can, between now and Thursday is the day of doom. And I do want to tell you that this is probably going to be the last time I'm going live in a couple of weeks because I'm having guests over, and so I'm not going to be able to do this for the next 2 Sundays. But if you do like it, I will try and put up some questions step by step in my normal videos. All right, have a great day, guys, and I hope this helps.